Hello, this is Captain Chaudhari. In my series of videos on basic stability calculations, I have already done about over 40 videos on stability calculations, starting from the very basic calculations. Today I'm going to talk about Drydocking once again. A person might think like what time, at what instant the GM of the vessel becomes zero and what are the implications. Basically, in most of the dry docks, as soon as the vessel ticks the blocks, that means as soon as the critical period is over, there are these additional blocks which are laid. They are called keel blocks, or in some dry docks like Kolkata, they put the poles on either side so that the ship remains balanced in the position, sitting all over, so that there is no fear of ship falling. Now, what we are trying to do today, just for the interest, just for the sake of knowing that what time the GM becomes zero, the virtual GM becomes zero, we will calculate. Hopefully, this instant of virtual GM becoming zero should happen only after the critical moment is over. So let's do this calculation. Here, the displacement of the ship is 5,200 kg, 7.6 km, free floating 9.6 meters, km at critical moment is 9.5 meters. This is the data which we have got from the stability book. Km at approximate upthrust, which is given at the final condition, that is when the GM becomes zero, and we are just saying the approximate P which gives rise to GM equal to zero. At that time, km is say 9.65 meters, right? Free surface moment is 600 tons meter, length 154, LCF 74, TPC 29, MCTC 240. We are required to find the drafts at which the GM virtual becomes zero. The present drafts are 3.64, 5.44 and trim 1.80 meters. As I always tell the students, one of the first equations you should write is P critical into LCF in the beginning. One of the first calculations which are done for Drydocking, right in the beginning, is P critical into LCF is equal to trim change into 100 MCTC. So this will give P critical as 1.8 into 100 into 240 divided by 74, that is the LCF. So 1.8 into 240 74 gives me 583.8. So P critical is 583.8. Now, whether it is required or not, I would always advise the students must find out what is the draft, what are the drafts at which the ship takes the blocks, or what are the drafts at the end of critical period. So using this P critical 583.8, let us find out the final drafts at which the ship will take the blocks. So starting with the initial draft as 3.640 and 5.440, bodily rise would be 583.8 divided by 100 TPC, that is 2900, gives me 0.201, 0.201, 0.201, 5.239, 3.439. Now the trim change would be same as the initial trim, because we assume that the declivity is zero, there is no slope in dry dock. So trim change is 1.8, so TRA is equal to 1.8 into LCF, that is 74, divided by LBP, that is 154. So 1.8 into 74. This gives me TRA, that is a change of draft purely due to trim change, 0.865, 0.865, and TRF is 0.935, 0.935. Forward is plus, this one is minus. So this is the even keel draft when the ship takes blocks all over, 4.374, right? So 4.374 is the even keel draft, and P critical is 583.8. Now let us do the main calculations. We want to find out what time the GM will become 0. Now the equation that I am going to put is Km minus Kg minus FSM upon delta minus P minus Pkg upon delta minus P equal to 0. So Km minus Kg is, I would like to take the Km, instead of free floating, I would like to take 9.5, because at the moment I feel that this would be a Km closer to the final condition Km. So 9.5 minus 7.6, that is 1.9, is equal to 1 upon, I can write FSM plus Pkg upon delta minus P. That is because this expression, when it goes on the other side, it would become positive, and the equation would be like this. So 1.9 into 5200, this comes on the left hand side, minus P, gives me FSM 600 plus 7.6 into P. So 5200 into 1.9 is 9880 minus 1.9 P is equal to 600 plus 7.6 P. So therefore this goes on the other side, this becomes 9.5 P, and 600 comes on this side, becomes 9280. So P will be 9280 divided by 9.5, gives me 976.8. P is equal to 976.8. It means that when the upthrust grows to this amount, 976.8, that is the moment when the GM virtual becomes 0. But luckily this happens after the critical moment, because at the critical moment the upthrust is 583.8. That means when the ship sits nicely on the blocks and it is additionally supported by the extra blocks, after that the upthrust grows to 976, and that is the moment when GM becomes 0. But this P I would call as P approximate. Why I call this P as P approximate? Because the Km that is used is not the Km for the final condition. I feel that instead of using the Km at critical moment when the P was 583.8, we should better use the Km at the instant when the virtual displacement is 5200 minus 976.8. That would probably give me more accurate P. Let us do the calculation. In the same equation, instead of 9.5, if I put 9.65, right? If I put 9.65, then the difference would become 2.05, right? And therefore the equation would become 2.05 into 5200 minus P equal to 600 plus 7.6 P. So 5200 into 2.05 gives me 10860 minus 2.05 P equal to 600 plus 7.6 P. This will go on this side, so it will become 9.65 P, and 600 comes on this side, it will become 10260 divided by 9.65 gives me 1063.2. 1063.2 tons. So when P grows to this amount, that is 1063.2, that is the time when the GM will become 0. So now we must find out what is the draft then. We know the draft at critical moment, that is 583.8. When the critical moment P was 583.8, we know the drafts fore and aft was 4.374. 1063.2 minus 583.8 gives me 479.4. So increase of P is equal to 479.4. Now we know that at critical moment the drafts fore and aft were same. So critical moment drafts were 4.374, right? And 4.374 is the even keel draft. It is also the hydrostatic draft. All we have to do is we want to know what will be the change of mean draft or what will be the change of hydrostatic draft. So the change of hydrostatic draft is going to be 479.4 divided by 100 TPC. So let us see, 479.4 divided by 2900, that gives me 0.165. 0.165 4.209 meters. So 4.209 meters is the draft fore and aft at which the GM becomes 0.